This is going to be a video to show a step-by-step construction on how to construct the cotangent function on Geometer Sketchpad. First, start off by opening a new document on GSP. Let's plot a point on our document, and let's translate that point, make sure that we're in polar, and we're doing it by 1 centimeter and 0 degrees. Let's change this to 0 degrees. Let's construct a ray from our original point to our translated point. Then let's unhighlight and select only the translated point and press Ctrl H to hide it. We don't need it anymore. We're going to just hide it. So we're going to construct a circle centered at our original point and drop the other point of the circle on our ray that we just constructed. From here, we're going to construct a segment, which is going to be our radius of our circle, and we're going to label the center of our circle as A and our intersection as B. Let's then hide this unwanted dashed line. So select the dashed line and press Ctrl H. From here, we're going to measure our radius. So select our radius and measure the length. And we're also going to select our radius and go to graph and define unit distance. What this is going to do is this is going to allow us to manipulate the size of the circle, and it will affect the coordinate system that we just created to the radius. It corresponds to the radius of the circle. So if I were to move this circle over here, let's do this, and line up the center of the circle with the origin, the intersection point B will always be on 1 no matter how large or small I make this circle. Notice how it's always going to be 1. So from here, what we're going to do is we're going to construct a line centered at A and intersecting our circle, and let's label this intersection point as C. Let's then notice how we're going to be looking at our arc length BC. So what we're going to do to get this arc length is we're going to select B, then our circle, and then C. Go to construct an arc on circle, and notice how it's a solid portion of the circle and the rest is dashed. This is the solid portion is what we are measuring. That is the arc length. That is the central angle we are going to be calculating in a little bit. So what we're going to do now is we are going to measure this arc length. So we'll only select the arc length. Go to measure arc length. We want to measure the angle in radians. So we're going to divide the length of the arc by the length of the radius to get our central angle in radians. So let's do just that. Let's go to measure, let's go to number, calculate our length of our arc BC divided by our radius AB to get our central angle in radians. And let's label this, right click, go to properties, label, and label this as theta. This is an important value we're going to be using later. From here, we're going to select AB and point A, and we're going to construct a perpendicular line intersecting our circle. And we're going to label this intersection as D. We're also going to select point D and our segment AB and construct a parallel line to intersect our line that we constructed AC. And we're going to label this intersection point as point E. To make things a little bit more appealing, what we're going to do is we're going to construct three segments, DA, AE, and DE. Unhighlight and select only the dashed segments, the dashed lines I mean, and we're going to hide these, so press Ctrl H. The segment DE is our cotangent line, which is the one we are going to be measuring. So let's measure DE. Select DE, go to Measure, Length, and we are also going to be measuring the X values of D and E as well. So let's select E and D and go to Measure the X values. One thing I want you to note is as I move C along our unit circle, as I approach this end of the circle, theta equals pi. If you notice up here, theta equals pi. And as I move along, it also equals 2 pi. Alright, so let's select segment DE, and let's make this red. We're also going to emphasize our segment DE, our cotangent line, and our arc length BC by making our circle thin, or hairline if you prefer, and these three blue segments also hairline. So let's do just that. This is strictly to emphasize what we are intending to measure and look at over on our coordinate system later in this video. From here, we're going to calculate our cotangent of theta. To do that, we are going to go to Number, Calculate, and we are going to select our X value of E minus our X value of D divided by the absolute value of our X value of E minus our X value of D. This portion of our calculation is strictly to note the change in sign of our function. We're going to multiply this by the segment DE, our cotangent line, divided by our radius AB to get this calculation. And let's label this as our cotangent of theta. Go to Properties and label this cotangent of theta. From here, we're going to plot our theta and cotangent theta on a coordinate system over here. And we're going to select theta and then cotangent theta in that order to get our xy points, xy value points. So select theta, then cotangent of theta, go to Graph, Plot as xy, and notice how we get a point over here. We're going to have our point selected that we've just created and select the x-axis, and construct a perpendicular line to intersect our x-axis, and let's mark this point, this intersection point with a point. From here, we're going to construct a line from our origin to the intersection point, and we're going to show the correspondence between our central angle, our arc length BC, and our cotangent line DE. Our cotangent line DE is going to be this segment right here that is going to be displayed as red. So let's right click, go to thick, right click, it already is solid. So let's hide this dashed line, Control H, and let's select this other line that we constructed and show the correspondence to the central angle or the arc length that we constructed. And let's make this solid and thick as well, and make this green, since our arc length was green over here as well. So as we move point C along our circle, we can notice that our coordinate system over here that we created also gets affected. And as you notice, the point that we constructed, theta cotangent theta, it moves along a similar path of the cotangent function. We're going to justify that by right-clicking. No, we're going to select this point, and we're going to go to Edit and Action buttons, Hide Show, so we can hide it and show it. We're going to right-click, and we're going to trace the plotted point to show just how the point moves when we animate our point C. So we're going to select point C, make another action button, go to Edit, and create an action button that animates. Notice how it is, point C is counterclockwise around our circle. You can adjust the speed if you would like. I'll go slow just for this example so you can see the correspondence. And as I click this animation button, I want you to notice the path that this particular point makes along our coordinate system and how it is directly related to the cotangent function. Notice how it intersects at pi over 2 when our cotangent line is 0. And in addition, it will intersect at 3 pi over 2, which is also when our cotangent line is 0 as well. Thank you for watching. I hope this video was very informative.